Okay, everybody, we're going to go ahead and get started. Good morning, good afternoon, and good evening, depending on where you're joining us from. Welcome to the March 2017 edition of our CA Mainframe Security Community No Fail Friday webcast series. My name is Len Thompson. I'm the Community Manager for the Mainframe communities here at CA. Before I hand you off to the Mainframe security team for introductions in the session itself, just want to let you know that I'm recording today's session and we'll be posting a replay out in the community later today or on Monday morning. Also, I know that most of you are listening to this session via the WebEx audio broadcast, so if you'd like to ask a question, please use the Q&A feature right within the WebEx. If you don't see that box in the lower right of your screen, just click the question mark icon in the upper right and it will open up for you. And with that housekeeping out of the way, I'll hand you off to Matt Dooley to kick us off. Take it away, Matt.
Thanks, Len, and good morning, everyone. Thank you for joining this month's Mainframe Security No Fail Friday webcast. I'm Matt Dooley, Product Marketing Manager at CA, and today we are going to be playing hide and seek with our latest innovation, CA Data Content Discovery. So today we have Jeff Cherrington and Marianne Furno from the DCD product team to take us through that. And with that, I'll give it away to Jeff and Marianne.
Matt, thank you very much, and Lynn as well for arranging this. We do appreciate that you take time to get together with us. Marianne and I are with the Mainframe Security Group here at CA, and what we mean to speak to today is something that we are finding has a particular sense of urgency and relevance to a number of our customers. What we intend to do here is we'll not spend a great deal of time with slideware after we make an introduction, but look to get directly into some practical demonstrations. I will make a bit of an introduction to set the stage around the dangers of dark data. We'll have Marianne introduce CA Data Content Discovery for those who may not have been aware of it previously. But then what we're going to focus on is what we're hearing from our customers. They say that they want to exercise a game of hide and seek, if you will, to prove that CA Data Content Discovery actually does as it is advertised to do, because if it does, it could become a very important part of their complement of applications and tools to improve their security posture and, perhaps most importantly, improve their compliance posture, particularly for those organizations that may be subject to the EU General Data Protection Regulation, or GDPR, which goes into effect in a year from May. We'll probably expand on that as we go forward. We'll do some practical exercises. These are the things that our customers are asking to do to prove to themselves that DCD, CA Data Content Discovery, actually performs as it is advertised to do. And then as we go through, Marianne principally will act as the voice of the offering and talk to some best practices. We'll conclude with a recap. We will look to speak to your questions. Please do use the Q&A pane in your WebEx console. We will be looking at that as we go along, and we'll try to catch questions that come in during the session if we're able. To open the discussion, one of the things that we want to share with you, we have to give credit to Veritas for completing the research and advertising it, but it reflects exactly the sorts of conversations we've been having with our Mainframe customers, particularly through the voice of our Mainframe Strategic Advisory Council, who say that there is an enormous amount of risk in what they don't know. There is an unknown in every data center related to dark data. That is data that is not tagged, it's not classified, it's perhaps not even reviewed with any frequency. As it shows here, the Veritas survey showed that as much as 54% of data in the enterprise is dark. And our customers are saying to us on the mainframe that these lost, abandoned, orphaned data sets could be containing any amount of critical, regulated, or sensitive data. And at the conversations that we started, they felt like there was no good means or opportunity for them to automatically locate, classify, and then address this dark data. And the consequence is that there was an unmeasured amount of risk should any of these data sets escape their control, become compromised or exposed, whether through simple error or by actual fraudulent intent. So, Marianne, with that setting that every enterprise suffers from the risk of an unknown amount of dark data on their mainframes, perhaps then you could tell a little bit more about the context and what we offer to address that.
Sure, Jeff, thank you. The dark data problem is years in the making, with mainframes running in enterprises for decades now. It's not a problem that ages out quickly. A data set containing social security numbers or other personally identifiable information that was stored on the mainframe in the 90s may have been perfectly okay at that time. However, multiple things have changed since then. One, we live in an always-on environment today where connectivity to the mainframe, to the rest of the infrastructure, and even the internet exists. And the second, we have more and more regulations emerging that have taken foothold to protect our sensitive data, such as PCI, the General Data Protection Regulation that you referred to earlier that is on the horizon, and many more at the federal and state level. Now, what happens is, if these records are compromised, whether it's accidental or intentional, these can cost an enterprise $200 US or more per record. Playing hide and seek with this is a risk most of our organizations are keen to avoid. One CA customer recently took data content discovery, and in the first 100 data sets that they scanned, he found 5% or more contained regulated data, which was an unexpected finding on his part. Even if one of these data sets had been compromised, even if it was by accident, this could have cost this customer millions of dollars. So we're here today to show you how to win the game of hide and seek with your regulated and sensitive data. Data content discovery was released to the market in November of 2015. It is the first product to run and scan data exclusively on the mainframe. It does not duplicate data, so it doesn't exacerbate the dark data problem. We have provided an intuitive, modern user interface to set scan criteria and browse results, and it doesn't require in-depth mainframe knowledge. The product is zip-enabled to help you avoid increases in charges on the general CPU consumption. And we integrate with all three external security managers, our own ACF2 Top Secret and IBM's RACF, to show you who has access to this sensitive data.
So is that back over to me then, Marianne?
That is back to you, Jeff. Thanks.
Okay, super. So as you see from the graphic that we put on screen, the left side represents the world that many of our mainframe customers are facing today, where they have an unknown amount of regulated data that is potentially harmful to the organization, represented by the I guess that's sort of a brick red colored representation in the the circular arcs. And their world changes then, as we see on the right, where they have something available to them in CA data content discovery that lets them automatically find the regulated or sensitive data, classify it, and then take appropriate steps to protect it. And this message is resonating well with the market. In our first year of selling the product, of making it available to the market, we've gotten over 40 customers, I believe, here by the end of the day today. We'll be able to say that with confidence. And they're beginning then to adopt it, apply it, and use it to reduce their risk and reduce their potential liability. So the customers who've done this, though, have done it with a good deal of prudence. And one of the things that we've heard repeatedly is, show me. I'm from the virtual state of Missouri, if you will. They say, show me that all these claims that you make about CA data content discovery, being able to find my hidden data, my lost data, I want to believe in it, but I need you to prove it to me. And it was actually through the voice of a customer that it came forward to say, I want to play hide and seek. I'll hide some data on my mainframe. We'll have a install of DCD in for an evaluation, and I want to be able to prove that it is finding this hidden data, because with that, I've got a better sense and confidence that it's actually finding all of the regulated data, because that's my goal. As I work with auditors, as I work with regulators, they ask us to make attestations repeatedly, constantly throughout the year, that we're protecting all of the payment card data or all of the personally identifiable data. And right now, I can say with good confidence that we do have excellent controls in place for our production data, but I have no idea how much other data might be residing someplace unexpected on the mainframe, as Marianne pointed out with one of our very first customers. So I need to have confidence that I can find all of the data that I need to be addressing. And so with that, we're going to drop out of the screen share. Marianne and I are going to actually play the two principal roles that you would expect. With a situation like this, Marianne is in the role here of our customer, and I'm going to play the role of the customer administrator, perhaps, who has been brought in without necessarily a great deal of knowledge, which is sort of reflective of my current state here when it comes to where Marianne is hidden data on the mainframe. And so she will be the person who is posing the challenge, and I will be the person who's been brought in to see if I can solve that challenge. And in this first particular instance, we're going to play hide and seek to find PCI data, payment card data, a payment of primary account numbers of debit cards with CVCs that includes the checks to make sure that the 16-digit numbers we're finding are valid in terms of having a loon check in the 16th position, a check digit, if you will, as well as having valid bank identification numbers, or the first 6 digits of a payment card number that used to route it through the payments networks. And in this, we'll do some demonstration of some capabilities we haven't shown in some of our prior webinars on DCD, compound classifiers, and a proximity filter. So I'm going to shift from the PowerPoint over to the user interface. We'll go ahead and log in, and here you see what any new user would be presented with: the graphical user interface for CA/DCD that is suitable for any level of mainframe expertise, which is, again, excellent for the role I'm going to play, because right now I don't even have authorities to log into the CA mainframe with the 3270. So Marianne, you're the person who's hidden the data. I'm going to start by asking what it is we want to look for. It seems like we were going to look for primary account number and for the not check digit, but the verification numbers, the 3-digit numbers that are on the back of the card that are frequently used when doing online transactions or telephone transactions. Is that right?
That is right. And I'm going to help you out here, Jeff, for the purposes of our demo time that we have today. As you walk through, I'm going to help you out just setting the scope of your scan so that we narrow it down and we can run the demo in the time allotted.
Okay. And as I think about this, we're looking to find 2 data elements here. We want to find both the primary account number, the 16 digits of the payment card number, and the 3 digits that represent the verification number. What would be best for me to do? To go directly into creating a scan, or is perhaps there another step I would do first so that I can make my scan as efficient and with as few false positives as possible?
There's another step that you would do first. So we're going to go into classifier management, and I've set up a compound classifier for you to right there, yes, the compound classifier, and you can see the second compound classifier in the list is 2 classifiers compounded in an AND condition. So when you set your scan up, if you choose to use this compound classifier, it will look for the primary account number and the CVC together, and then you have the choice at runtime either in file proximity or in record proximity.
Super. That sounds like it'll be very helpful for what it is we want to do here as we're playing hide and seek. It's also a good representation of the breadth and scope of flexibility that CA data content discovery has. It certainly provides a long list of out-of-the-box classifiers, and in fact, that's what we're leveraging here. There's an out-of-the-box classifier for primary account number, and there's a out-of-the-box classifier for CVC. Here in this case, though, our challenge is to find those 2 elements in proximity to one another within a single record. And so this compound classifier gives us an excellent opportunity to achieve that, again, with the fewest false positives. So as a neophyte user, I know I want to create a scan. You said you'd throw me a lifeline, Marianne, in terms of the scope of data that we want to search. Certainly I could do something that might search the entire CA mainframe data estate, but that might take longer than we've got here for our demo. What would bound my search here for this particular conversation?
So Jeff, let's take a look at running scans against the high-level qualifier HS for hide and seek.
Okay, so hide and seek, we'll use that as a high-level qualifier. I'll enter in a couple of asterisks. We'll wildcard this to look for all data sets that are related to that particular high-level qualifier. We don't know how many there are. I certainly don't at this point. But I'll also note for the audience that if this were perhaps a real-world example and not one that was time-bound by our webinar, a customer who's doing this would use perhaps SMS storage group and do a very broad search, or volume and do a very broad search, or perhaps take a look in database tables. But in this particular case, because we do want something that we know will fit our time box, we're going to use data set with a high-level qualifier and wildcards. This is set up in a wizard that makes it very easy for a non-mainframe user to use, something that most of us are familiar with, conditioned that way by Microsoft and other PC-oriented vendors. I have the opportunity here to exclude data sets if I had some that I know that I'd already searched and didn't need to look at. we're not going to do that here, but I'll also point out that there is a standing do not scan list that is part of any installation. Perhaps there are some files that you know, because of their nature, are never going to be something that are sensitive that you need to scan, or they have been searched previously and you've got them locked down so they can't change. We do have a standing do not scan list here that we'll include. And now we come to the point where we can start refining the search to focus on exactly what we want to find. As you recall, Marianne created a custom compound classifier for us, CAN CVC compound classifier. I'll select that. And we're going to indicate that in terms of proximity, we want to find those two data elements in the same record. That's really all we have to do to configure this particular scan. I have the opportunity to add some controls around word boundaries. That's something that we'll explore in a future webinar perhaps. And I could include one or more email addresses here to create alerts that can be very useful. Alerts to let people know when a search starts and when it completes, since some of these could be potentially very long running, or more importantly, and probably more practically, could be run by the scheduler in batch. It might be useful to know when a particular search starts and completes. We won't necessarily do that now, but here we'll give our hide and seek test a name, bit of a description, and make sure that it is configured to run immediately. We're not going to wait for the scheduler or for batch because we want to demonstrate this to you now. As with any well-made contemporary application, I have the chance to review and make sure that what I've configured meets my expectations. If not, I could back up and correct it. But in this case, we're just going to go ahead and run that scan now. And just as one would expect from a well-behaved modern application, we begin to get feedback immediately. There's a notice that the scan is running. I have a visual representation here that gives me an idea of progress. And indeed, the progress bar, as you'll notice on screen, is showing activity. And there we see, as it refreshes on your screen, that it actually completed. So Marianne, here then, as the role of somebody at an organization, an administrator who's working with the interface, what would I do next to understand what the results were?
All right, Jeff, go ahead and click on the name of the scan, and we're going to go into it and see the details of what was found. So up at the top of the scan in our header, we recap the scan criteria, but more importantly, down at the bottom, you will see that including a scope of our high-level qualifier, HS, resulted in the discovery of two different data sets, hs.data.visa and hs.data.adder. In this particular scenario, we were looking for payment card primary account number along with our card security code. You can see the top two rows against hs.data.visa. There were 100 rows in the file that were scanned, and 99 of those records had the payment card account number and the card security code in record proximity to one another. Jeff, do you want to see the data?
I do.
All right, let's take a look. I'm going to go into my data set, and here are the two data sets that fall under the HS high-level qualifier. I'm going to go and browse hs.data.visa, and you can see this is what my data looks like. It has our simulated and test primary account number starting here, and we go through our card security code right here. So you can see this data. Let me page down so you can see the entire file here. This is the data that resulted in 99 matches because the primary account number and the card security code were found in record proximity to each other. Make sense to you, Jeff? Jeff, are you on mute? Len, can you hear me?
I can hear you, Marianne.
Okay, so Jeff may have fallen off. All right, so let me continue with the demo then while Jeff dials back in. So I'm going to back out of QWS. Let me set up under HS though. I'm going to go back into the UI and just review the results that we found. So under our hs.data.visa, I'm going to go ahead and click on the rows with matches, and this will tell us exactly within that file what records DCD found the matches in according to the criteria in this instance. So you can see 1 through 20 on the first page, and if we go on, you can see all of the different rows here and records represented.
So, Marianne, can you hear me? Am I back online?
Yes, I can hear you now, Jeff.
Yeah, you're back, Jeff. Thanks.
Oh, thank you. Yeah, I apologize there, folks. Something interfered with the phone connection, and it dropped me. So Marianne, I'm picking up here, I think, where you were speaking. And what I'd like to relay to the folks here on the phone and for us to exercise are, again, the sort of questions we're hearing from the field. As you can anticipate, when it comes to payment card, there are different parts of the buy-sell chain of the payment cycle that get involved. And while everyone is concerned about protecting payment card data, because if they don't, they could be actually dropped from the payment network, and that would have catastrophic impacts on their ability to generate revenues. Those organizations, the banks and financial institutions that actually issue credit cards, are the ones that have the greatest potential risk and liability. If a merchant or a merchant acquiring, a merchant transaction acquiring bank allows a cardholder's payment card number to be compromised, certainly they have some liability and they have some risk. But when a card issuer lets their own cardholders' payment card numbers become compromised, the risk is much greater because they then would end up being responsible for the charge-offs for any fraudulent activity. So let's again, playing the roles that we've adopted here, let's take it to the next step. We've identified that we're able to find any sort of payment card number with good acuity, with good reliability, and to ignore things that are not payment card numbers. But what about if I were here playing the role of a CA customer and said, you know, this is important, but what I'm most keenly interested in finding is the payment card numbers of my own customers. How would we go about that?
What we can do is we can take the banking identification numbers that have been assigned to me, and I can set up a table of those. And you can see I've done that here. The last record in my data dictionary has a range of banking identification numbers in it. I'm going to go ahead and take a look at that table. And the data dictionary is what is used behind the scenes in some of the classifiers, either out of the box or custom classifiers that customers can create. So this particular...
And Marianne?
Can you hear me, Jeff?
And if, I can. And if we can interject, for those of you who may not work with the electronic payments industry, the bank identification numbers are typically going to be shown as the first 6 digits of the credit card or the debit card number. This is what's actually used by the Visa, the MasterCard, and other payment networks to switch transactions, authorizations, and postings. So they are something that are going to be an element of any credit card or payment card number and would appear in that data. Back over to you, Marianne.
All right, so I have created this data dictionary for you with our keywords, in this case being the VIN numbers, and I have already associated it to a classifier. So I'm going to let you walk through setting up a scan just as you did using the VIN classifier that I have set up.
All right, so should I then go back and create a new scan?
Yep, start back where you did for the previous scan.
I'll create a new scan then. I'm assuming we're going to use our same high-level qualifier.
We are.
We're not going to exclude any data sets. So what should I do now to configure the appropriate classifier scan pattern?
In this case, you want to go all the way down to the bottom of that option menu where it says Dictionary-Based Classifiers, and you want to select the classifier called VIN Table. That is the classifier that is connected to the data dictionary that we just presented.
All right, I've done that. What's my next step?
Go ahead and progress through the scan criteria wizard just as you did the last time, and we'll kick off the scan.
And so just as previously, I will go through the panels of the wizard, give the scan that we're doing here a name so that we can easily pick it out of the list, make sure it's configured to run immediately, review it to make sure that I've got my data sets in there and the classifier that we selected, and go ahead and run that scan. Again, we're getting our immediate feedback. It was submitted successfully. We see it appear on our list as it feeds from the top. Now, of course, anything that we do here with CA data content discovery is work that is perhaps non-production in nature. In other words, it may not be something that's part of the mission-critical workflows of a given day, and certainly that is reflected in the best practices that we bring forward to customers about how they should assign priorities. We would never want to see something like CA data content discovery take priority over critical production jobs, and so consequently there could be times when we would see a job run longer than we do here as it's waiting for resources to become available. This one did complete nicely, quickly here today, and in fact what we see is the result that might have been expected. Whereas previously when we ran the scan just for any payment card number, we found that there were hits in the data.visa data set, and there were 99. However, now there's only 50, and if I click on that link, what it shows me is a view of exactly what record number that particular classifier identified data in. So previously, we saw that the data that was being found when it was just a generic payment card identifier started with the very first record that was in the data set. However, now it says it's only in row 51 and later. Marianne, is that correct?
That's correct, and let's just double check it. I'm going to go back into our data set. We're going to browse our Visa data set again, and I'm going to go to record 51 here, and you will see that we had 4319 for this 41 through 55, and that is what we see reflected in these first 6 digits of our data towards the latter of the file.
And so what this has done is provided a representative example of the sorts of dialogues we have with our customers as they seek to use the offering to achieve their goals with the minimum amount of false positives. There's a tremendous amount of capability available with CA data content discovery right out of the box, and it becomes even more potent when organizations use some of the capabilities that are included, such as compound classifiers, such as custom classifiers, such as custom data dictionaries, to refine the scans and the searches to the point that they are focusing on what's important to them and setting aside the potential for significant false positives. So as we're coming here close to the end of what we've set out to do, we'll return to the deckware for just a moment, because we've focused here so far on payment card, because that is a very robust part of the industry when it comes to the need for managing regulated data and ensuring that data privacy. But we're also finding, as I said at the beginning, that there is keen interest in doing these sorts of exercises for personally identifiable information, particularly in the context of the EU General Data Protection Regulation. The range and scope of attributes that fall into the category of personally identifiable information is very broad. The definitions that are included in the language for the EU GDPR or for the U.S. Graham-Leach-Bliley Financial Modernization Act or any of the state data breach disclosure regulations varies significantly, and in many cases they use only the broad language to say you must protect, you must keep private any data that could be used to specifically identify individuals. Well, in some of our recent conversations with customers, they've said, well, we want to be convinced that we can find records that are perhaps residing in the 50% of dark data that we have in our data center that are related to European citizens. And the example that I think that we've heard here most recently is we want to be able to search and find records that contain driving license numbers for citizens of the United Kingdom and their addresses, because those two attributes in combination are a very clear identifier of an individual and could be used for identity theft or to compromise critical information about them. So, Marianne, we'll resume our respective roles here. If we were to drop out of this deckware and provide a demonstration of that, how should I proceed?
We are going to start setting up a scan. We're going to use a custom data dictionary compounded with an out-of-the-box classifier in this case. So Jeff, we're going to target the same scope of data sets that we had in the previous two examples.
So I've entered data sets mask hs.** with the wildcards. We're not going to exclude any data sets. Okay.
Right. Okay, in this case, then we're going to go to the custom compound classifier menu item, and we're going to choose the UK driver's license and the street address compounded classifier.
All right. And I believe that we're going to want to again use the proximity control so that we're searching for this in a single record, yes?
Yes.
We'll continue on then through the process and skip through to the steps so that we're getting to what's interesting in the respect for our listeners' times. We'll make sure again the scan runs immediately. The configuration looks correct, and we run the scan. The other sorts of questions that we have heard from customers that have some significant interest, as I mentioned earlier, there are particular best practices that can be used to ensure that the priority of jobs for DCD do not interfere with the priorities for production work. We also frequently get questions about performance. When customers are interested in performance, we do have some useful benchmarking that can help them understand exactly how much capacity they might need to survey a particular data estate of a given size in a given period of time. Many organizations are interested in that because they think about adopting this offering as they anticipate upcoming regulatory audits or IT practice audits, and they want to make sure that they can schedule sufficient capacity to meet a particular goal within a given period of time, whether that is executing on a zip processor or an IBM specialty processor, as all these workloads are fully specialty processor eligible, or even in circumstances where they may need to process the scans on a general purpose processor. The scan has completed here. As I was providing that bit of discussion, we see it has completed, and as we take a look at the results, it appears, as we would expect and hope, there were no false positive hits in the data.visa data set. But Marianne, it looks like we did get hits for driving license number and for address in 3 rows, 3 records of the data.adder data set. And it appears that those attributes were found in records 1, 60, and 80. Is that correct?
1, 60, and 80. Let's take a look. Let me get back out of our visa data set and go into our address data set. I'm going to take a look at record number 1, and I can see a street name right here. I'm going to page over to the right, and I've got a UK driver's license number right here at the end of that record. I'm going to progress to, it was record 60, and page over to the right. We've got our street name right here. A page to the right now, and we've got our UK driver's license tacked on to the end. And lastly, on record 80, go back to the beginning of the file, we've got our, or the beginning of the record, sorry, we've got our street name here, and paging over to the right, we've got our UK driver's license number tacked on here. So yes, Jeff, records 1, 60, and 80 were correct. 3 places we found the compound classifier.
Tremendous. Thank you, Marianne. So let me underscore here as we begin to come to the end of this particular webinar. We've used the 3270 view that you see here, not because it's part of CA data content discovery, but because it gives tangible proof that we're actually winning the game of hide and seek. The sorts of scans that you've seen here have exactly reflected what we've been asked to do with our customers to prove that we can find personally identifiable information for particular geographic regions in just the way that you've seen. But everything that's presented here for CA data content discovery is available through graphical user interface that is suitable for any level of mainframe expertise. I think perhaps what we've been able to show is that we do offer a new capability that has never been available before now on the mainframe itself that gives you data loss prevention capabilities to find CA data content discovery and to classify the data as appropriate for the regulations or the best practices that an organization is looking to adhere to. Marianne, do you have some concluding statements here about the capabilities of DCD and what we've proven here today?
I do, Jeff. So the signs, we've got 10 different file types that we are able to target in the scope of scans, 120 plus classifiers out of the box, and the ability to customize them, compound them, create data dictionaries, and then the protect state integration into the 3 ESMs, as we mentioned, to identify who's got access to your sensitive data, who's taking a look at it, and another integration point with our Compliance Event Manager product to not only show you who can access, but we can take a look at who has been accessing that data. So Jeff, I'll turn it back to you.
Thank you very much, Marianne. So we've exercised a particular set of capabilities here today to demonstrate that using CA data content discovery, our customers can win the very perilous game of hide and seek that many enterprises are perhaps even unwittingly experiencing in their mainframe data stores. There's a great deal of other capabilities that are available with CA data content discovery, and we have a series of webinars such as this one, which are available for on-demand replay, to expand on some of these other topics, such as the one that Marianne just touched on. Here today, we showed you can win with hide and seek. In some of the other webinars, we might expand a little bit more on how we integrate with RACF, Top Secret, or ACF2 to give you a view of how, or I'm sorry, of who has access to data, and with integration with our CA Compliance Event Manager, not only who has access, but who has accessed particular data sets that are discovered. In just a couple of minutes here before we close, there are a couple of questions that have come in. The first one is intriguing. It says, I am interested in learning more about this. I'd actually like to exercise the hide and seek. How much does it cost to arrange for a trial of DCD? Well, we appreciate that question. The thing that we want to assure you is that we do support no-cost evaluations of DCD. You have the options of installing directly on your mainframe, on your premises, or on your mainframe provider, and that is frequently a very attractive option, in particular because DCD can install in as little as a day. We have proof cases where customers are installing on Monday and running their first scans the next day on Tuesday morning. We have cases where customers are actually installing DCD successfully by themselves without our direct support. So we think that you'll find it's very lightly landing in the data center. But if that's not convenient and you still want to exercise the offering to make sure that it does as advertised on the tin, we also provide hosted evaluations or hosted demonstrations. We have customers who are looking to get familiar with the product, to assure themselves that it performs as advertised, working directly from our own CA mainframe. We have some other questions about the range and the scope of classifiers. We didn't show everything that could be shown there today. As it says on the screen, there's 120 plus classifiers. What are some examples? So in the context of the European General Data Protection Regulation, GDPR, we focus on some of the most critical data elements first, such as national identifiers. And there's a range and scope of national identifiers that are relevant. There are the national insurance numbers that may be appropriate for localities in the UK, as an example, or in Canada. There are national identifiers associated with driving license numbers that we support for a number of different European countries, and there are national identifiers associated with passport numbers that we also include for a number of European countries, as well as the U.S. and other countries in other geographic areas. And just one last question here before we go. related to the General Data Protection Regulation. The question coming in says, Jeff, you've mentioned GDPR several times. We understand that that could be very important for organizations in EMEA, but we're a U.S. company. Why would we worry about that, or we don't have to worry about that, do we? The question is a qualified no. You may have to worry about that. The way the language of the General Data Protection Regulation is composed states that any enterprise anywhere in the world that is managing or holding personally identifiable information related to European citizens is subject to GDPR. And consequently, they voice the right to impose the stipulations and, most importantly, to impose the potential penalties. And the language does specifically state that the penalty for violating the General Data Protection Regulation can rise as high as 20 million euros, which would be just about $20,100,000 in U.S. as of today's exchange rate, or 4% of worldwide revenue for a year. So the penalties are actually very, very stiff, potentially, and they are extending their reach to any place in the world where there are EU citizen personally identifiable information on file. So if you have customers who are in the EU, if you do processing for people who reside in the EU, you could potentially be liable. So that concludes the session. We're going to close this out now, give everyone a chance to prepare for their next meeting. Certainly, if you're listening to this now and you have additional questions and would like to know more, please feel free to contact me, jeff.cherrington@ca.com, or marianne.furno@ca.com. Marianne or I, either one, would be happy to respond. And the same extends to those of you who will be listening to this webinar on-demand replay. We invite your questions, and we certainly invite you to put CA data content discovery to the test and prove to yourself that it could help you win the perilous game of hide and seek with dark data on your mainframe. Marianne, thank you very much. Matt and Lynn, thank you very much. And to all, have an excellent day.